Root 2, that's a surd, because 2 is not a square number. Root 3, that's also a surd, because 3 is not a square number. But root 4, that's technically not a surd, because 4 is a square number. So we would usually just say that root 4 is equal to 2, and that's it. When I'm saying root, I actually mean square root. People use them interchangeably, so I just wanted to be clear that I'm talking about the square root when I say root. Okay, so now that we know what a surd is, let's talk about the rules for manipulating them. Manipulating in this context just means working with. So rule 1, multiplying. Keeping it generic for now, we can say that if we've got root A times root B, that's equal to just root A times B. So as an example, if we've got root 5 times root 2, that's equal to root 5 times 2, or just root 10. If we've got 3 root 2 times 2 root 5, if we deal with the numbers first, so 3 times 2 would give us 6, and then root 2 times root 5, as we saw above, is just going to be root 10. So altogether 6 root 10. Now these rules do work both ways. So we've said that root A times root B is the same as root A times B, but you can also go backwards, and this will become more important a bit later on in the video. There is a special case of this rule, and that happens when you've got root A times root A. So two surds that are the same times together. What happens here is that that is just equal to A. Now the reason for this is root A times root A, as we can see from the original rule, would be equal to root A times A, or just root A squared. Now the square root of A squared would just be A. As an example with numbers in, if we've got root 3 times root 3, that's going to just be 3. Next rule, dividing. So if we've got root A over root B, or root A divided by root B, that's the same as root A over B. So if we've got root 10 divided by root 5, that's the same as root 10 divided by 5, or just root 2. Last rule is adding and subtracting. Now, an important note here is that surds work in the same way as algebra. I wanted to point that out because when we look at this rule, it's going to feel really similar to when we work with algebra. Root A plus root A is equal to 2 root A. If we think about that algebra comment I made just now, that's similar to thinking about x plus x being equal to just 2x. Now, just like in algebra, when we put two things next to each other, there's an invisible times symbol between them. That's the same with surds. So in between the 2 and the root A, there's an invisible times symbol there. Let's look at a more detailed example. So let's say we've got 2 root 3 plus root 7 plus 4 root 3 plus 2 root 7. Again, thinking about it in a similar way to algebra and grouping together the terms that are the same. So we've got 2 root 3 plus 4 root 3. That will give us 6 root 3. And then we've got root 7 plus 2 root 7, which will give us 3 root 7 altogether. The next thing I want to talk about in this particular video is how to simplify surds. And I've got 3 examples for you. Example 1, simplify root 50. This means we want to break 50 down into smaller numbers and surds where possible. I'm going to show you 2 different ways of doing this and then talk about which way I prefer, but it is up to you. Way 1, we write root 50 and we think of any 2 numbers that multiply to make 50. So for example, root 50 can be split into root 5 times root 10. Now, remember I said earlier that the rules work both ways? This is an example of that multiplying rule working backwards. So we're splitting the 50 down into 2 smaller numbers. Now, I'm going to keep simplifying this by breaking those numbers down into smaller ones where I can. So root 5, I can't split into anything else because the only way of doing that would be root 5 times root 1, which wouldn't be helpful. So I'm going to keep the root 5, but I'm going to split the root 10 down into root 5, root 2. Then I can see we have that special case where we have 2 surds that are the same multiplied together. So that's going to give us just 5, and then the root 2 stays as it is. So the final answer is 5 root 2. The second way is the way I prefer because it involves a shortcut. What you do is you take your root 50 and straight away you try to think of 2 numbers that multiply to make 50, one of which is a square number. So root 50 can be split down into root 25 times root 2. Now the reason it's a shortcut is because we can say straight away that root 25 is equal to 5 because it's a square number. So that leads us straight to the answer, which is 5 root 2. That's the way I prefer because it saves a bit of time, but ultimately you will get to the right answer even if you do the other way. Example 2, write 5 root 27 in the form k root 3, where k is an integer. First things first, what is an integer? That just means a whole number. So they want us to break 5 root 27 down into the form k root 3, where k is just a whole number. So 5 root 27. If you leave the 5 on the outside for now and just focus on the root 27, I'm thinking of a square number that goes into 27, and I'm thinking 9, and that will be root 9 root 3. The square root of 9 is 3, so we can say 5 times 3 root 3, and then altogether that gives us 15 root 3. Now that is in the form that they want because we've got 15 here, which is our k value, a whole number. Third and final example, really similar to the one before, write 7 root 20 in the form k root 5, where k is an integer. Again, leaving the 7 on the outside for now and thinking about how to break 20 down, we can say 7 and then root 4 root 5. I've chosen this because it's the shortcut method. Root 4 is just the same as 2, so we can have 7 times 2 root 5. Which gives us 14 root 5. And again, that looks like it's correct because we've got a whole number, 14, for our k value. So that's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And please do share this with anyone else that you think might find it helpful. Thanks, and see you next time.